So I get that everybody's tired. It's been a long week. It's been a long week for us as well. So we, as you can tell by the colors, we have been at RISC-V. And this is actually the deck from the RISC-V conference that just happened. And for us, that was the moment when we actually came out of stealth and announced a lot of things coming to open source. And this is one of the things that we wanted to share today. And initially, our talk for this AI Plumbers was called "What is Missing in the Ecosystem?" But instead of asking that question, we actually want to suggest finally some answers. So again, it's not the first AI Plumbers we're doing. The whole idea is to discuss the plumbing, the stack, the engineering part of AI. So what does it take to make things work? And that means lots of things. So end-to-end use cases, like how to connect, how to integrate different blocks. It's all the actual blocks that we want to discuss, like open source components, because again, we're all for open source. So this is what we do. And that's why we also brought a lot of open source building blocks. And the, kind of the problem that we want to talk about is around the infrastructure stack going down to the hardware layer, going down to the chip. Because if you try to solve the kind of the stack itself, you try to figure out the all the layers, and they might be optimized whatever you want, but then the hardware kind of is a common denominator, then you lose a lot of competitive advantage. And like this is how the industry tries to answer this question, and I'm sure like all the open AIs in the world have figured it out. They have it proprietary that works, they optimize as much as they can, but that's because they have the whole control over the whole stack. And if you look how the kind of open source industry tried to answer that question, it's kind of all things to all people, because there were a lot of different types of models, different architectures. There were a lot of different kind of evolving frameworks. There was obviously a big ecosystem of different silicon companies, and everybody kind of tried to make it all work on everything. And again, I'm not against it. I'm actually like think for the discovery stage of the industry, it's really, really important to move as fast as possible. But it also kind of leads to creation of all these abstraction layers that, again, become common denominators, and kind of you lose performance on every stage. So now, like, everybody comes and says, I want whatever DeepSeek is having. We heard that so many times. It's like, I don't know what they did, I want the same. And like, again, people try to answer that by combining different companies, but that's not an end-to-end thinking. It's like, we have some building blocks, we put them together, they kind of work, but it's not like you can control the remaining part because it is closed. So what happened is, and what has always been a winning combination, is a chip co-evolving with the software. And that is not new. That happened, like that's why NVIDIA and CUDA made like such a strong moat. That's why like TensorFlow goes with TPU. It's again, they co-evolve together, and that was really important for the training stage. Then NVIDIA, like with PyTorch, again, ultimately it's a very co-evolving framework with NVIDIA. But now we kind of come to the inference era, and it seems like training and inference has bifurcated quite like far from each other. And if you're doing training, I mean, NVIDIA is great, Cerebrus is great, but it's like it's kind of becomes the place for large companies, large enterprises, probably even hyperscalers only, that can actually do that at scale. And for the rest of the world, there are open models that are really good. And everybody's asking, how can we run them? How can we inference them? And if you look at the inference era, there are a lot of new frameworks that are emerging, so like GGML, ZML, TinyGrad. And now the question is, what accelerator, what chip can they be co-evolving together? And our answer to that is the open ecosystem. Because we are not NVIDIA, we don't have that much money, but we are open source people. And what open source people do is create a community that has shared interest and shared goals. So that's why we opened a bunch of building blocks. You can go to our GitHub, there is a QR code, and you can start looking at them. There would be more coming. So we have opened the software, the firmware, we opened the emulator, so you can run it even without access to the hardware. We also have a bunch of machines right there that you can nicely ask us and we'll give you SSH access to. If you really nicely ask us, we will give you PCI cards, because the current thing that we have is it's a prototype. It's useful to do the software stack and to show the capabilities, but we'll talk more about like what we actually are offering as an open platform. So these are the principles that we believe in. And again, like, these are not new principles. They're very common to open source stack. Like, if you want to optimize a stack, you need observability, you need controls, you need a way to actually do that. Again, like, you can't do it on proprietary extensions that like by RISC-V. RISC-V is a great ecosystem. I mean, you still can do some proprietary things, but open them. Like, it doesn't have to be like all standardized, but at least people have to be able to kind of examine it and make their own opinion of it. We also like really depend on quantization work, and there would be more talks today about that, because that is also allowing us to optimize chips quite a lot. You don't need that much of floating point anymore, and that is all because of quantization. And on that note, I will actually allow Roman to talk more about the architecture.
Yeah, and hey everyone, I won't actually spend too much time on the architecture because Gianluca, right after this, will be, giving you a detailed tour of it. But I just kind of wanted to highlight the following, right? If you think about, the evolution of our industry, right, and how the open platforms, evolved, one of the great examples, I guess, would be LAMP stack, right? LAMP came out when, web was a hot thing. And, Linux, Apache, MySQL, PHP, right? But there's also a silent letter in that because it's not LAMP, it's really LAMPi, right? There's I at the end that nobody pronounces, because if you think about it, right about when LAMP came about, right, Intel was shit. Right? Like, Intel was not competitive at all. It was, really this thing that, maybe a PC that you would be running would be good, but like, I was at Sun Microsystem at the time, right? We were laughing at them. Like, how could you possibly put something like that in a data center? And then, of course, now, all you have in a data center is an Intel-based system with, some AMDs, of course, but it's still Intel architecture. And I think, that co-evolution, that basically kind of, again, I mean, obviously Intel co-evolved with Windows as well. I mean, that was a strong push, that hence, the name of Wintel. But that Linux bit co-evolving with the application layer, co-evolving with the chip is what gave us the infrastructure for the internet. And we're kind of making the same point. Let's get opinionated, right? Because at the end of the day, I mean, it wasn't FreeBSD, which was also available at the time. It wasn't, I don't know, OS 2, which was also available at the time. It was very particular opinionated piece of software called Linux, and opinionated obviously because of Linus Torvalds. I mean, you cannot get any more opinionated than that. So let's get opinionated, right? So like, our take on this as a community, and we're offering this, right? We're actually open, to debate, but like, I think we need to get opinionated. So if we need to get opinionated, we basically kind of really have to follow this principle, less is more. And just in the good old days, you kind of start at the application layer. Now again, nowadays the application is the model, right? The model itself is the compute. So like, you start with that. And effectively, like, my joke for all of the cloud providers has always been, actually starting from Sundays, because I used to be at network.com, I'm like, if you can run top 1,000 Docker containers at every given moment in time, you're okay as a platform. Like, nobody cares. It's like Google, right? When you do Google search, like, nobody clicks on the 10th, page. Like, it's like 1, 2, maybe 3. Like, that's it. Like, as long as you're not lying on those pages, like, you're a good search engine. Nobody knows what happens on page 10. Same here. Like, as long as you can run top, and you can sort of make up the number, 500 model from Hugging Face, like, you're good to go. Now, again, obviously, there will be proprietary models and this and that. But if you talk to the customers, most of the time they start with Hugging Face, and that's the application layer. So then you kind of need an inference server, because you need to like put it into something. And again, we suggest that we get opinionated between basically kind of just a few things. Let's not spread too thin, right? So Llama server, is super useful because again, a lot of these models you will be taking from Hugging Face would be in GGML, in the GGUF format. So like the easiest way to kind of like throw them into some, infrastructure is to just use the Llama server. Triton, and we will have, some talks, from NVIDIA guys today. Triton was one of those things that was also useful because you could just throw Onyx model into Triton and call it a day, right? Recently, Llama server by itself is kind of like a little bit, maybe clunky. I don't consider it clunky. People do, it's fine. Hence Llama, which is a separate story. But I actually like, Docker model runner because it kind of like takes the same ethos that Llama tried to, pioneer and basically just puts it back into the open, right? Docker people are actually great in taking things that are kind of like proprietary and making them open. Like I love them for that. So I suggest we do that. And again, I mean, inference frameworks obviously flows from what I said, GGML, Llama, CPP. I actually suggest people are like, well, you still have to run, Onyx. Like, yes, absolutely, you have to run Onyx. I mean, you don't really have to run, like TensorFlow formats anymore, like that kind of gone. But Onyx, you have to. Now, my personal take on Onyx is that there is this, how many of you know about TinyGrad? Now, there's actually a decent amount. Do you guys know that, the best way to run an Onyx model, actually way better than Onyx runtime, is TinyGrad Onyx frontend? Well, now you do. So, I mean, because TinyGrad has always been looking for that frontend, and they were ambitious enough to really commit to like really doing a PyTorch frontend. Nobody should commit to doing PyTorch frontend. Moves too quickly, breaks things, And again, like it's a good ecosystem. It's just keeping up with it is very difficult. But Onyx is a much slower evolving ecosystem, so their Onyx frontend is really, really good. Now, finally, that missing I, right? Because I keep saying like LAMP is not just LAMP, it's LAMP I. So what's I in that? Well, now we have in that open sense, right? Because again, if you think about Intel, not at the level of the chip, because that wasn't really required back at the day, but at the level of the architecture was the first open architecture that we had, right? Because we used to build computers, like Sun used to build computers, but everything about that computer was proprietary and closed, right? The chassis, the motherboards, like everything, right? You couldn't repair that computer. Like you couldn't buy like an extension card from, anybody but Sun. Well, I mean, later on that changed a little bit, but like still. So Intel was that open architecture, and we need that kind of an open architecture. So we're basically saying, let's get opinionated down to the RTL. So now we have a really nice ISA, which is RISC-V. And if we create that open architecture, maybe we could have that opinionated stack just for inference. Again, no training, as Tanya said. Like training is way too big and way too complicated. But for inference, I think we can just get going with those building blocks and hopefully be as successful as a LumPy stack. I'll skip all of these slides because, again, Gianluca will get into much more details about what we propose is that, RISC-V based architecture. So I'll just leave you with this. This is actually like we had to block the exit, but, that system is here. We demoed, this little box, it's kind of like a eGPU type of an enclosure, but like a fully contained box with our cards. So you can play with that, scan a QR code and just stay here for the conversation. And if you disagree, just, let us know.